Well, good morning and welcome to our panel on IoT security and privacy. My name is John Howie. I am the Chief Privacy Officer with Huawei in their Consumer Business Group. And I also have a role in cybersecurity as well, but it's not as big as my Chief Privacy Officer role. Huawei has decided to sponsor this panel today because we think that IoT security and privacy is going to be a huge debate in the future. It is not my goal today to drive the debate. I'm going to rely on Professor Antón from the US to drive the debate amongst our panelists, and she's going to introduce them to you shortly. I just want to open up, though, or precede the debate with some remarks. You had to have had your head in the sand if you didn't see or hear about the Mireille botnet attack in the last few months of last year, which had a crippling effect on the internet infrastructure, taking down content distribution networks and DNS providers for some of the world's largest websites, consumer-oriented and business websites. And it had a practical impact on companies and their revenue. And the Mireille botnet was different from previous botnets in that it did not target home users or personal computers. Instead, it targeted IoT devices and home routers and gateways with default passwords or vulnerabilities in the code of, say, Internet Protocol video cameras, such as baby monitors. So there was definitely a new element to the attack. Not only was it the largest, most crippling attack, 650 gigabits of sustained throughput at one point in time, it leveraged consumer electronics to be successful. And that is the first time we've seen that on this scale. And as we move into an era where there will be more and more IoT devices connected to our home networks, smart appliances, where we will have more IoT devices connected through technologies such as narrowband IoT or low-power WAN or 5G communications, there is a need to step back, take a pause, and look at the practical implications. Are we doing the right things in security and privacy when it comes to IoT in order to defend ourselves from these styles of attacks in the future? So that's all I'm going to say in the matter. I just wanted to set the stage, if you will, for the debate, and I'm going to hand it over to Professor Antón.
Good morning. So I come to this as a technologist, not a lawyer, and I'm an American. I've taught a course on privacy, technology, policy, and law for over 10 years now in the United States. I'm a professor and a school chair at Georgia Institute of Technology in Atlanta. Most recently, I did a lot of work with IoT with respect to President Obama's Cybersecurity Commission, of which I was one of the 12 members. If you haven't seen the report, it looks like this. It's available on the NIST website in the United States if you're interested in reading it. This is intended to be a document to make recommendations to the transition team for the next president of the United States. It was a bipartisan commission. And in the report with respect to IoT, I think one of the biggest themes was the recommendation to shift the burden away from the end user and to place that burden on the manufacturers and engineers who are designing the products in the first place to make sure that IoT devices are secure by default. And so I'll just throw that out there as an underlying theme. I'm very curious about your thoughts on that. I think one of the other things that themes for me is interesting is that as an American, one of the things that strikes me as different from the EU is that we really focus a lot on tinkering and exploring and innovating without really knowing when we're developing a technology which of the uses or which of the things that we're tinkering with might actually stick and have a great market value. And so I'm curious about that model, how that works here in the EU, and whether, what guidance can we give to engineers and manufacturers as they're developing new technologies in such a way that we're complying with law, and I know that the GDPR is also perhaps changing some of this, and I'm curious about the framework and in terms of the implications for us as technologists. So we have four wonderful panelists today, and I'm going to introduce them one at a time. So first I'd like to ask Ana Maria Fimin from Romania originally, and she's with the European Commission DG CNECT. If she'd like to start things off for us today.
Thank you. Good morning, everybody, and it's nice to see you as well here in a numerous number today, as I've been already attending the last 2 days, and there have been brilliant discussions, so I hope this panel will do you the same justice. I'm here to speak on behalf of the European Commission and explain what are our actions in relation to this field of work, Internet of Things, and express some of our some of the challenges that we have identified in relation to the privacy and the security dimension, as well to explain which are the legal frameworks in place which could tackle these challenges, and as well some complementary measures to already the existing legal frameworks. I would like to start by saying that digitization of our societies and industry, it is at the heart of the EU agenda. That's why we believe that digital technologies such as Internet of Things, but not only, are able to are enablers for such a process. I've already also prepared a couple of slides on this. So, in order to set the scene, what is Internet of Things, I'm sure you all know. What I would like to emphasize is the fact that it mainly means connecting everything and everyone to the internet, so that we have in place new services, but as well that these technologies help us to go towards better management of our resources of any kind, starting from environmental resources, but as well we think in the smart in the cities environment, so on and so forth. And in terms of socio-economic impact, such intelligent and connected systems are expected to boost productivity by 30% in the next 10 years. You already had the previous panel already discussing some of the Internet of Things use cases. I would just like to bring to your attention this smart home. So if we think about this home, which is equipped with sensors, with robots, and connected devices, such an environment would clearly make an easy life for elderly people, allowing them to live in their homes safely, but as well in an independent manner, as well even sometimes avoiding institutionalized care by keeping them remotely in touch with the doctor. So we can see all sorts of tangible improvements which in fact would reduce pain and would allow better mobility and quality of life. As well, think about smart agriculture. From a farmer's point of view, smart farming should provide the farmer with an added value in terms of better decision-making processes, and as well in more efficient operation and management. So we all know that IoT, having in place all sorts of sensors, deployed on groups, on our animals, and so on and so forth, allow for the collection of the vast quantities of information, which basically allow to improve productivity, but as well costs. There are indeed a lot of potentials ahead, but there are clearly as well implications of this technology. I would start with the security dimension, and I think this part has only briefly discussed this 2 days, but we strongly believe that there is no privacy without the security of these devices. Here we talk about the right to life, so it's not the right to personal data, but it's the right to life, and the main implication is, of course, death or severe health damages. The main causes that may lead to this is not only cyber attacks, but it may also be the reliability of the device itself, but it may as well be a misuse from the side of the users. Already some famous hacking episodes which can lead and have led to the threats of safety of users. One vulnerability we see is related to the medical health devices. Apparently, it's not so impossible to connect to the device and stop its functionalities, and this would actually have a severe health implication. And we know already that some US presidents have refused to have pacemakers in order to sort some of their health problems. In terms of privacy implication, of course, we talk about constant surveillance. This has already been discussed here, but we have identified recently some new privacy challenges. If we, for example, look at the connected toys. So on top of all the other, the smart TVs, the webcams as well, hackers can take control over a toy and start discussing with our children in their homes. The implications can be severe, and I would just end maybe with setting the scene with this slide. It comes from a Nordic Association of Consumers. They have done research on how the terms of services of this network, so network of this of the all these social networks we have around. If we analyze the terms of conditions for such platforms, we actually realize that there is legal ground to claim that the consent we have given for the way our data is being used can actually be challenged, and this is related to the fact that it is basically impossible to read the amount of words of such a terms of service. It is also impossible to understand to what exactly we commit to, giving the type of wording used, and as well, it seems also difficult to read it, as it is provided in a format that doesn't make it very readable for the user. I would stop here with the challenges and the potentials of IoT, but we will continue further with the legal frameworks and the EC action plan on how to tackle this implications.
Terrific, thank you. I'd like to continue now, and we'll come back for more discussion and a little Q&A as well afterwards. But I'd like, Jeremy, I was wondering if you might be willing to share some with us. Jeremy comes to us from Microsoft, and he's a public policy expert, and that's his base, and so we look forward to hearing from you now. Thank you.
Thank you. Can you hear me? All right. No, thank you for the introduction, and I'll be very brief because I think we would like to allow for enough time for question and answer. In the panel description, we talk about the IoT opportunity by the numbers, and I think it was cited that there was, in the abstract of our description of the panel, that there would be 20 billion connected devices by 2020. We had a report from a few years ago that put that number at 50 billion. A year later, Morgan Stanley was saying that that would actually be 75 billion. And then we had a report more recently than that put it at 212 billion. So I think everyone has their own numbers, but as we can see, the opportunity is enormous. And based on some of the scarier stories we've seen, based on some of the holiday shopping patterns, I think we're seeing an increasing amount of connected devices. And I think we're seeing an increasing amount of positive stories coming out of industry and new insights and opportunities that are coming about with Industry 4.0 modernization and some of the new learnings we're getting from more and more connected devices and the collection of such corresponding data. So in this very realistic image of the connected world that I think we all see, it's super positive. We see a lot of connected devices, and we see a lot of new opportunities for retailers, for businesses, for citizens. But at the same time, it's very easy to see that many of these things create vulnerabilities. I'd like to focus more on the positive aspects of IoT and that earlier slide where I think we can have a dynamic, connected environment that we're getting a lot of productivity gains from, we're getting a lot of new insights from, we're getting a lot of new innovation from, but we certainly wouldn't minimize the risks that come with an increasing amount of connected devices. I think the good news is that from our perspective, I don't think that the security and privacy principles have necessarily changed with IoT. It's simply that the attack surface, or attack vector, as we sometimes say, has expanded significantly. So with that comes increasing responsibilities for an increasing number of actors. I think everyone has some degree of responsibility in that space, and I think it's something that we certainly recognize with more and more of the move to the cloud that I think we see as current dynamics and future dynamics. So when we say IoT, we're also talking a lot about cloud computing. None of this is really possible without the cloud. In that attack surface that I mentioned, again, you have security vulnerabilities potentially at the device level. You have security vulnerabilities and privacy implications for data in transit. And then, of course, we have security obligations and considerations and privacy considerations for the data at rest. And that, in a way, kind of explains Microsoft's approach to securing IoT in that space. Whether it's at the device level, we don't have, most of our business is not as focused at a hardware level per se, but we are working with our hardware customers and hardware partners to ensure that such devices meet higher security standards, and that includes customer audits from the ground up, ensuring that devices are designed with security in mind as privacy by design principles, even for hardware manufacturers. And when we come to data in transit, of course, we start to highlight things like our encryption credentials and more of the tactics that we're using to ensure such data is adequately protected. And we have a lot of regulation already in place that would put that into such a context of where the protection needs to happen. And then, of course, within our own cloud, I think we're very proud about the level of security and privacy protections that we put in place. I think, though, nonetheless, you had talked earlier about some of the breach and attacks that occurred. We employ teams, or red teams, as we call them, based on a principle of assume breach. So we have people working for Microsoft that are attacking our own systems every day to find those vulnerabilities and ensure that we're finding them before the bad guys find them. So I think I wanted to keep it very short. I think there are a lot of things to consider. I think the challenges are certainly there. We have a much, much broader attack surface than we did before. But in terms of rethinking all of the principles, I think I would argue that much of our security principles, much of our privacy principles, data minimization, purpose limitation, the security development lifecycle that we've had in place at Microsoft for a number of years, much of that remains valid. We just have to apply that to an increasing amount of actors. And despite some of those challenges, I think we see tremendous opportunity here, and we're seeing it in a variety of sectors. We're working with people from everywhere, from engine manufacturers to tech firms to farmers that are really, really getting more value out of the insights that can come from more connected devices and that IoT space. It's not to minimize any of the risks, but again, I think some of the good news there is that companies are recognizing that demand from customers. One of the first questions you often get when we're there saying, hey, let's connect all your devices, let's move to the cloud is, what do I do about privacy? What about the security implications? So I think we're competing with many in this space to sell our products and services in such a way as to highlight why our solution is more secure and provides greater privacy protection than others. And I think if you see that competition continue to be stimulated, I think that'll lead to some more positive outcomes and greater protections for customers and users.
Thank you very much, Jeremy. Given this landscape, it's a really nice segue now to Mireille Hildebrandt, who comes to us from VUB Belgium, the university. She's a lawyer, but she also works very closely with computer science. I believe has an appointment also in computer science. So one thing that everyone here has in common is that we all dabble in several different fields, which I think is great. But if you wouldn't mind walking us through your thoughts.
Yes, let's walk you through my few slides. So there's a lot of talk about privacy by design, data protection by design, security by design. Maybe it's interesting also to talk about deficient by design and to raise the question, the sort of risks that the IoT has in terms of making our entire physical, and that means in this case, cyber-physical environment deficient by design. It's obvious that nobody's looking for that, but I believe in constructive distrust here. And I'm also going to be a bit counterintuitive. I'm going to say, in opposition to many people who say that the principle of purpose limitation is of the old days and doesn't work in the era of big data, I think this is one of the principles that, both from a data protection perspective, but also from a perspective of methodological integrity concerning machine learning, a very necessary principle to build a safe IoT system. And I want to share with you first, if this works. Yes, it works. A tweet I sent around, I think, yesterday or the day before yesterday, where I encountered a tweet that said, I registered for a running club, my bank immediately sent me a fraud alert. Apparently the only reason I'd exercise is if my card was stolen. Now, of course, this is a funny anecdote, or it's maybe not funny, not that funny. But it says something about the idea of correlation and about the fact that this entire cyber-physical infrastructure and devices that we are now constructing that are already around. Think of cloud robotics, think of smart and connected cars, autonomous cars, think of the smart grid that is being built. Smart grid basically means that our entire infrastructure of energy, the most critical infrastructure for an environment that entirely depends on electricity, is being run over iterative machine learning applications. And I retweeted that. I always like jokes on Twitter. And I added to it, data pseudoscience thrives on data obesitas and pattern obesitas. So data obesitas to me means that a lot of governments, companies, and this will certainly explode in the case of the IoT, want to have more data, because there is a mantra that if you have more data than the law of the large numbers, which is actually a statistical law that applies in very particular situations, and you can't just apply it to human behavior at all. But that there's this idea that if you have all this data, which will be generated by IoT devices, we're going to solve all the problems in the world: security, privacy, hunger, and some other major problems. This urge to create ever more and bigger data flows, I call data obesitas, because there's going to be a lot of irrelevant, inaccurate, incorrect, and incomplete data around. And it often costs very much money to cleanse data. If you have bad data sets to train your algorithms, you get bad patterns. And that means if you believe that the patterns that you see in the data refer to real problems or real patterns in the real world, You're going to solve perhaps problems that are in your data set but not in the real world. Then you might also solve them at the level of the data set while they're not in the real world. Pattern obesitas, to give you an example, if you train an algorithm of a data set of animal faces, unsupervised machine learning, artificial intelligence, that algorithm is going to see animal faces in anything you present it with. So if you give it a flower, it will see animal faces in the flower. You can go online and see examples of this. I think it's called Dream Machine. So what I'm trying to say is the belief that big data is going to solve all the problems and that machine learning will come up with a new reality is a dangerous belief. Now, I believe that these cyber-physical systems that we are now working and that I think are extremely interesting and can have an enormous added value and can indeed solve a lot of problems, though we must acknowledge that they will also create problems. They will, first of all, I'm not even talking about data protection yet, require rigorous methodological integrity to prevent system breakdowns, because we're making ourselves extremely dependent on these systems. And of course, it's not only about system breakdowns, but also a frustrating everywhere, and the term everywhere is, of course, a pun. It's about everything everywhere. I believe that such methodological integrity in turn requires things like agile computing, so domain experts and data scientists sitting down together trying to flesh out what data are needed, what is the purpose, what is the possibility, what more data do you need, how do you clean them. What happens if you train an algorithm, this type of algorithm on this data set, and then train another algorithm on the same data set? Do you get another outcome? What does that mean? What if you train these algorithms on this data set, and then on another relevant data set, and you get another outcome? So create testability and contestability. And I think that fits very well with agile computing. And of course, the Internet of Things, many people are saying that now because of the enormous amount of exchanges, will require edge and fog computing. That means a lot of the computations will be done on devices or in the close neighborhood of devices. All that requires informed data minimization. So ask yourself the question all the time, is the data that I'm processing now necessary? Because you want to reduce unnecessary data, noise, data that will confuse the algorithms and train them on something you actually don't want to see. Now, I believe that the legal principle of purpose limitation, aligned with rigorously testable and contestable development of soft-wired hardware, would be able to save us from a lot of deficiency by design. And I think we'll leave it at that.
Thank you very much. And finally, our fourth panelist today is Erik Luysterborg from here in Belgium with Deloitte. And so he doesn't have any slides, but I'm sure that we have.
Thank you, yes. Unconsultant-like, I have no slides, and I also will try to make it as short and sweet as possible. So I run the EMEA Data Protection and Privacy Services within Deloitte. And my angle here is just what I would like to do in 5 minutes is a little bit set the landscape of what we see, where all of the issues that were raised, how that affects companies throughout EMEA that we've seen. First of all, it is important to see that there's some bad news in the sense that security and privacy is a little bit of a party crasher at this time for Internet of Things. The good news is there are solutions both on the security and the privacy front. The not so good news is it will take some time. And we're talking here about 3 to 5 years, I think, for some of these developments, and it's going to be a bumpy ride before we get there. Let me clarify. If you look at the issues that the companies are today at stake with respect to Internet of Things, it's threefold. First of all, you have to make a distinction between if you're talking about Internet of Things for the consumer if you're talking about Internet of Things in the context of companies, business context, or if you're talking about in the context of critical infrastructure. If I'm talking about consumer, it's from your fitness bracelets to what have you, to webcams and so on. If you're talking about in the business environment, it could be fusion pumps, it could be jet engine propulsion kind of maintenance and so on, and linking that to whatever a pilot who's the way how he flies the plane and so on, to infrastructure where it's really like smart meters, where it has impact on electricity supply, gas supply, and all of that type of stuff. The risks from a security and privacy perspective will be different, or the emphasis will be different in each one. If we look at the security layer, security and Internet of Things, Internet of Things security is not a specific security discipline on its own. The security issues are known, and they are known from on-premises, and they're known in the cloud computing world. So they're not the things, so the solutions and the issues are known. The challenging part is, and I come back to what I said before, is in the design. The problem that you have with, especially in consumer and Internet of Things, is what are the characteristics of such a device or such a system? Because let's face it, from a security perspective, it's not just a device, it's the fact that you are operating data in a system, in an environment. The device itself you can say the criteria of that is it's low cost, it's low power, and it has to be very interoperable, interconnected. The low cost is one thing, but the low power is also another one, because that means low computer power, so you have less power to put very powerful algorithms for, let's say, encryption. So here you have this flaw by design in the security of this, that first of all on the device itself, but second of all on network security and all of these interconnectivity, that you don't control that, and that there are no, at this moment in time, let's say widespread standard protocols for that. So from a security perspective, you have known issues of the fact that encryption is lacking or not complete. You have lack of authentication possibilities. For instance, if your webcam or your home kind of whole automation, the camera does not make a distinction if the instruction will come from me in Belgium or from somebody back there somewhere on the North Pole. It will just say, I seem to have an instruction to move the camera from right to left. It will not question itself, or at this moment in time, if it's really Erik who is authorized to do so. So these are known. What makes security as a bad thing is, in this case, we have an interaction between the virtual world and the real world. Shutting down all the lights in this building doesn't seem so as a problem. It's a nuisance. But if you're somewhere stuck in an elevator or you're stuck somewhere in a subway, it can become dangerous. If somebody doesn't allow you to open the door from your house and it's on fire, you can die. So the security gets into physical security. What is interesting is that trigger, because of the grave consequences for personal safety, will drive security kind of as solutions, and that it will be included, and that there is a focus on. The question now is just from a commercial perspective and from a technical perspective, when will we have the power to implement all of these known solutions to known problems on a security level? I'm very confident what we see, and also that's what we see in our clients, that these are not insurmountable from a security perspective. From a privacy perspective, it's a different kind of kettle of fish. From a privacy perspective, and I agree with what you just said on the secondary purpose and the purpose limitation, one of the major issues that we see that clients focus on is function creep. That means that you have collected information through a device that is perceived that people know it's for my fitness, it's for my heart rate, but you're actually going to use it through the internet connectivity and the access by other parties for other reasons than initially it was proposed. It can be accidental. You can have with your kind of fitness watch, if somebody hacks that and they kind of know if you're at an ATM and you're doing your code, by the way you move your hand, they can actually kind of find out your PIN code, those type of things. But also, if we are collecting data on the workings of a pump, an insulin pump, in itself, that's fine. But if you start linking that to the surgeon or to the nurse, then you suddenly are entering into the personal sphere. So the other problem, besides function creep, is the fact that in lots of these Internet of Things devices, you do not always immediately see Are there personal data being gathered? You might think it's not. It's just mechanical, it's aggregated information. But by interlocking all of these components, suddenly you will have kind of these personal information. And the final part in privacy also is the sheer magnitude of data and interlocutors make it so complex that the accountability and the transparency principle will be very hard to match. Remember, in an IoT environment, you have the user of the thing, you have the developer of the device, you have the manager of the information of the device, and then you have all of the intermediaries that have something to do with making sure that the information gets from A to B. That who will do what with respect to privacy is a whole other story. And I think that's going to be one of the biggest challenges that we see that for clients going forward is how are we allowed to use the data? How can we correlate the data? How can we retrace it to its original purpose that we wanted to use it for? So all of that, to disclose what we see, the solutions that are there and that people are kind of using is, one, is a bottom-up approach, that you have to build in the coding, in the device itself, the security elements, and also in the network. From a privacy perspective, it's a give-and-take situation. We talked about connected cars. Today, you have in a number of cars, you know this button that you can press and that people will know the emergency services. If you kind of flip over, you're somewhere on a lane, it will issue a signal, and people will not only know that you're there, but also in which direction, so that ambulances can get to you very fast. Now, for that, they need to track you. But what a lot of car constructors are doing is they're tracking you in bits of, let's say, 500 meters, and they delete after a while every time, so that they don't know where you're coming from, but they do know where you are. That is, to me, a reasonable implementation of privacy by design. And I think what we are getting to is we're going to get to a world in IoT that we will not have only privacy or security by design, but design by privacy and design by security. And that this translation exercise is going to be crucial, together with the whole governance. Because remember, for instance, in infrastructure, critical infrastructure IoT, smart meters, suddenly information about somebody's usage in a home of devices is going to come into hands of people who are not trained or not used to deal with that type of information, or have not secured it, or not have gotten the training. That type of governance element should not be forgotten next to the technical elements and the procedural elements. That's a little bit my intro to that topic.
Thank you very much. So as you see, we have 4 completely different approaches at looking at this problem of privacy and security with respect to the Internet of Things. Anna, you mentioned the security vulnerabilities, and you mentioned the privacy implications of those. And I'm wondering what regulatory guidance has there been here in the EU for privacy and security, and how does the GDPR change that?
Yes, thank you. I must say that I agree with already what our colleague from Microsoft and Deloitte have already expressed. In terms of the, before presenting the legal frameworks, I would also like to mention that the European Commission has put forward this year a new team working only on Internet of Things. So now we have more resources dedicated to this field. And on top of the regulatory frameworks that we have, the Commission is doing also a lot of work on funding researchers that want to come up with privacy and security solutions. So there we have a lot of grants under the Horizon 2020 work program, but as well we work with stakeholders on standardization processes, so that we can somehow enable a single market, a European single market for IoT. In terms of the legal frameworks we have discussed in relation to the privacy dimension, then clearly the GDPR will come in force next year. Some of these articles have already been discussed among several panels these 2 days. I agree with Jeremy from Microsoft that in fact some of the new provisions are only there, are made a little bit more clear or more specific to the point, but the current legal framework on data protection ensures enough of provision so in order to deal with the IoT privacy challenges. Some of the articles that are new and we could emphasize in this discussion relate to the principle of accountability. So this is a new principle, but we would need to see how to implement it in a complex value chain of an IoT device. A new aspect to be mentioned is the need to put in place to draw impact assessments. And this is mainly for processing which may result in privacy high risks. We have Article 32, which discusses the security of processing. So here we talk about the security of the data infrastructure. As well, in terms of remedies, now clearly we can, there are higher sanctions for failure to notify the data breaches. And in terms of data subject rights, I would like to emphasize the right to compensation and liability. Already was discussed the first day about the idea the need to have remedies in order to avoid that things don't go wrong. So now we can claim damages in case of personal data breaches. Going back to the security dimension, the Commission working with stakeholders and the ENISA have managed to put in place a framework dealing with securing critical infrastructures. The framework is not yet in place. It will be enforced in 2018. But basically, the DDoS attack would be covered by this DDoS attack that happened recently would have been covered by this framework as it was linked to a critical infrastructure. The problem is that not, as already Deloitte mentioned, not all the IoT applications are linked to a critical infrastructure. So all the smart appliances we have in our connected homes, it may seem that for that scenario there might be a security gap, and this is not present in any of the legal frameworks we have so far. That is the main reason why this year in 2016 we have launched a set of actions related to Internet of Things, and where we talk about a human-centered IoT. And one of the subset of this action plan relates to the creation of a trusted environment. How can we create this trusted environment? There are several options. One could go for certification, and here we'd like to talk about this IoT trust label, but the trusted environment could also be emphasized through standardization processes, putting in place the right standards where there is need for that. But it may all as well be industry-driven initiatives. Already the previous panel presented the works of the Alliance for Internet of Things Innovation, which is basically a platform gathering almost all the IoT actors on the market, and they are discussing the idea of putting forward a charter for that would gather some security and privacy codes of conduct. This is one of the streams of work we now have in place. We've already organized several workshops and debates with the stakeholders on the idea of the creation of this IoT trust label. That would mean that the idea behind is that society should be comfortable with the way IoT products and services are set up. We may think of baseline requirements in relation to privacy and security, but may as well be solid requirements in relation to these dimensions. Of course, after hearing the stakeholders, there are different views on this topic. We have, of course, big high-tech companies that may see this as a burden, and we know they already comply with the regulations in place, and they have put forward, as already exemplified by the companies here, they have a strong security and privacy codes of conduct. So for them, this kind of instruments may be seen as a burden, but there are ways out. They could just simply be granted this certification scheme. There are interests from other IoT sectors like the semiconductors, which are indeed providing all these sorts of solutions. So they are eager to have such an instrument in place. And there is also interest from SMEs and smaller innovators, which would benefit from this instrument to enter the market and promote their products. We are now in the process of engaging with stakeholders, but as well the member states. We know that Germany as well would have liked to put in place such a label, but they consider it is more opportune that EU does it, so that we have a uniform implementation of such an instrument. So on top of the legal frameworks, the certification schemes that we could have in place, the Commission is also currently looking at the product liability rules in the context of Internet of Things and autonomous systems. What we have actually noticed is the fact that some manufacturers decide to split in their terms of services different components of an IoT device into products and services. And thus we know the current extra-contractual regime we have in place at the EU level would only cover damages related to the product components. As for the service components of the IoT device, that is left to contractual arrangements, and these contractual arrangements may indeed go towards eluding the liability aspects. There is a public consultation in place now. I think the previous panel has already mentioned that, but you have there the link. So we are currently encouraging you to go back to the public consultation and give your thoughts on how product liability rules in the context of IoT should be designed. So there is a lot of work ongoing, but the EC is clearly willing to make sure that Europe is becoming a leading region in this sector, and that's why we're looking for smart regulation and smart actions, and we are clearly engaging with you, so just provide your views.
Thank you. So Jeremy, you mentioned that the attack vector has expanded, and so there's an increasing responsibility for all actors in the ecosystem, and you walked us through the Microsoft Azure IoT suite. One important actor in that ecosystem for IoT is the end user. And I would argue that those of us in this room are not the typical end user. And so we all have a heightened awareness and concern about privacy and security that really does not reflect the overall population. And so what is Microsoft doing to ensure that we are taking that into consideration and helping the end user and trying to prevent the types of malfunction and errors based on user interactions with systems?
I think that's a very good point. I think what we're doing more broadly is we want to make it as easy as possible for the end user to keep those decisions as small as possible. I think when we talk about that attack vector, it's bigger than even the way I described it, because there are IoT developers, there are IoT solution deployers, there are IoT solution operators, and all of that then gets drilled down even further when you start looking at the different sectors. So you're right, end users have varying levels of familiarity with these devices, and that's going to vary from consumer-based products to more enterprise-based products, and vulnerabilities can pop up anywhere. You know, I would be hesitant to put too much responsibility on the end user. I certainly don't want to shift the problem there because of all of those other roles that I mentioned. There's so much more that can be done in that space, particularly adhering to certain principles. That's one of the reasons why we are in favor of codes of conduct, particularly some of those that are envisioned in a privacy context under GDPR. But I think you want those to be rather sector specific. There are going to be different focus for people at a hardware level, at a hardware design level, at a hardware deployment level, versus a software design and a software deployment level. And if we're talking about security software, we're talking about engineering software, we're talking about design software. So I think it's a fair point. I think there's responsibility across the chain, naturally. But I think from our perspective, the better that we can limit the potential, understandably, sometimes poor decisions that maybe someone makes, the more we can minimize that, that'll be one of the better things that we can do in that space.
Thank you. I know in the commission report that I worked on, providing better usable systems, right, that really decreases the ability for end users to make mistakes is really important. And so I know that Microsoft is doing a lot of that space as well.
It's definitely harder to sell a dangerous product than it is to sell one with the right credentials that come with that. So I think we're trying to, once again, compete in that space to make sure that there's confidence there in the end user that using a product from a particular brand or a particular provider comes with some of those assurances.
And moving on to Mireille, you mentioned that when you have data sets that are larger than they need to be, right? And that you're using these data sets to train your algorithms, that you may end up actually solving a problem that isn't a problem in the real world. And so one of my questions for you, and this is kind of building on what I mentioned earlier about the approach in the United States, where a lot of times we're trying to be creative and to come up with new systems and new solutions that maybe would not have emerged had we not done that tinkering. So is there a tension there between really trying to create new technologies and new solutions thanks to machine learning that we hadn't envisioned possible yet, and the need to restrict the kind of data that we have in those systems?
If I understand your question well, you're asking about a trade-off, whether
Yes.
at some point there is a trade-off, so you have to say, we want all this new stuff, we want innovation, so sorry about the data protection, it has to go a bit lower. I think that in the security field, the public security field, so justice, law enforcement, and the intelligence services, this is a clear trade-off. I think that when you look at the data protection law, the current law and the future law, difference is not that big, that I'm not so sure that this is thinking in terms of a trade-off. This is more thinking default, we want to be able to process personal data. And IoT is about much more than personal data, of course, but as you already said, data that are on first instance not personal may get to be personal and help to very detailed, to profile people in a very detailed way. So I think the idea of a trade-off is a bit of a problem. It's like saying, now, somebody like a company or society is going to say, well, we have this right to data protection, but we just decided that because we like innovation so much, we are going to do it away. I wouldn't say that. I would say that the right to data protection itself has all kinds of built-in proportionality issues. Now, I think with the IoT, what is really concerning me, and there are a lot of other concerns, but what concerns me is that it will thrive on secondary use of data. Like you already said, you have this fitness stuff. You think it's going to be used for the service that is being sold for you. That's the second legal ground of Article 7 of the current Directive 6 of the GDPR. Contract, so quid pro quo. Now the whole issue is about the additional usage. So you have the data and now you want to use it for something else. You want to use it for creating added value out of the aggregate of data. To do machine learning, train your algorithms, and have all these fantastic solutions. Now, there I think the GDPR offers a set of very interesting solutions. Solutions in the sense of, let's face it, the purpose here is to predict behavior. That is the purpose. You're trying to experiment in the first instance, and then you will narrow down to predict this type of behavior, etc. Now, I would say that if you do that at this aggregate level, the GDPR first requires that you admit that this is your purpose, and you communicate it to people. They have to be aware before you start doing that, and you will need to have a legal ground. And I think we need to have very serious discussion about which legal ground is here. I think consent is not fair because people cannot really understand it. The legitimate interest of the data controller might be a ground, but it requires very complex blah, blah, blah. Okay, I think we must have that discussion so that people know where they're at and so that companies know where they're at, also governments. What is important is that once you have that ground and once you have your purpose and you have communicated it, the regulation, the directive, will require, for instance, pseudonymization. I don't believe in anonymization. From a computer science perspective, anonymization within 10 years is just a laugh. So the question is, how are you going to pseudonymize? And computer scientists have a certain understanding of what is pseudonymization, which is not always the same as the definition that the regulation gives. I would advise anybody, especially from the industry side, to read that very carefully and to look what is the idea. So the idea is that if you have data and you take out the identifier and keep it separate, as long as you keep it separate, organizationally and technically, you have pseudonymous data. And you can do train a lot of algorithms on pseudonymized data. And at some point, when you want to focus, you may have to add back the additional data. And I think that some people think that the GDPR is vague and people don't know what to expect. No, I think this is a very, very important flexibility in the GDPR, so that both the companies and the people can sit down together and say, and I'm also talking about the data scientists and the domain experts and companies, government, sit down and say, okay, how large is the interference here with your privacy? If you're putting down a whole lot of data and you're just training algorithms, I would say the interference is less, so you may pseudonymize, and if you have a good ground and you have communicated the purpose, that might be okay. But you must give people a chance to say, I don't want that. I don't want you to train algorithms on my pseudonymized data. I don't want to contribute to what can be done with the patterns that may be found. I think we need to have that conversation and see users not as oranges to be squeezed of behavioral data, but as partners that may want to be predicted. The problem with prediction is that it will lead to behavior influencing. Cas Sunstein has just written a book, The Ethics of Influence. I think that technological people, business people, citizens, us, we have to think about these technologies are going to influence us anyway. So if we don't think about it, well, somebody somewhere will decide about it. So we better think about it. When does the influencing become creepy because it happens behind our back? And when do we say, okay, we don't want to have a consent banner every 3 microseconds, because that's not realistic. But we do want this service, and it will require to predict my behavior. Like a smart grid, our energy usage will not work if we do not predict continuously energy usage. I'm convinced of that. So we have to interact with this. And I think that's extremely important. And I think that the GDPR gives a wonderful framework that will allow companies to act ethically. So it puts a threshold in the market and says, look, these are the requirements. Go figure out how to comply with them. And I admit that's not an easy job, but if you want innovation, you can't want to have very simple rules, because then you're going to be very in a rigid situation, and we don't want that.
So I'm going to ask a question of Erik, and I'd like to invite anyone who'd like to ask a question of any of our panelists to please join us while I'm asking Erik this question. Erik, as Deloitte has many different clients, different that you help. I'm wondering if you can tell us a little bit about the biggest problems and challenges that you see when you help your clients in this space, and also what are the biggest trends in terms of best practices that you're seeing?
Well, with respect to the biggest problems, it all depends, of course, for sector and again in which environment you're talking about. But generally, what you see, and this is on a security level, it is really kind of the lack or improper, let's say, access to network security and to interoperable standards. That's the first thing. The second thing is also within the device, within the developers, at the developers level, the awareness or the willingness or the possibility to build codes that are much more stable and much more secure than they are now. What I mean by now is, today if you look at just a simple, especially in consumer IoT, when you buy a device, even the password that's been brought with it is so simple that just the device not only can be hacked, but it can be used to do a denial of service attack or something like that. Those type of elements we see in the clients in how to build that in a commercial viable way, especially in consumer IoT. When you go in business IoT, so in the business environment, the pumps and all that, what I said, there it's more like about things because you control a little bit more the environment and you have the security elements. It's about intrusion detection. Is how quickly am I going to know that something is wrong? And then with that is the governance part. Who is going to do in this whole chain of all of these intermediaries from a security perspective is going to take up what? And that is not always that easy for our clients to see. I think from a privacy perspective, the biggest elements there is, again, it's really this secondary purpose. It's this function creep. It's the fact that you will have data at your disposal. You can use it for other purposes, you will connect it with something else, and suddenly you have a whole different profile and a whole different need. That is how to manage that properly within their organization, because they can have the policies and the procedures, but to actually kind of follow up that nobody does willingly or not willingly something wrong is difficult. The second part in privacy, I think, is also the risk of that all of these devices that are going to be connected are going to do something like the automated decision making on the basis of context, without any intervention. It could be that your car habit driving, if that is somehow shared with an insurance company, they can immediately use that for premium kind of calculations in the wrong way or in the right way. Those type of things is really something that, from a practical perspective, is hard to grasp because innovation is going very fast, but security and privacy is really lacking on these fronts. And I think the governance part with respect to transparency is the last bit that is really an issue. We are dealing with lots of interlocutors, we are dealing with lots of data, and an accurate data mapping and an accurate data inventory for, let's say, GDPR purposes is not that easy because there's no current best practice. And to come back to then, what is the best practices? They are very few. Because today, this is very new. If I talk about Internet of Things, there are a number of best practices that we can deduce from cloud environments and so on that already exists. So it's not that you can already, that you can't start. But privacy by design and security by design, which is really what this is called for, is at this moment in time, what it is, it's a principle. And we are hoping that guidelines that will come out from Working Party 29, from the local, we hope not too divergent from all of the local DPAs, data protection authorities, will help us a little bit in building what do you mean by embedding this in a process, how far do you want us to take the privacy by design. But that will be the solution. You mentioned software development lifecycle. It has to be translated into language that developers will understand, and I'm not saying they're dumb, by far not. But they are used to working in a certain kind of loop, in a certain kind of environment, use cases. You have to translate at each gate when they are thinking of the idea, when they're putting the functional and so on, what they need to do. And that will then drive better security and privacy. And that's what we're seeing what our clients are doing. These are the solutions that they're already putting forward. They are putting forward, without the lack of standards, they are putting forward what they think will work. And there are possibilities. But it's not ideal, and definitely not in the consumer IoT world, where I think that's more of a far west, security, privacy-wise speaking.
Thank you. So we have several questions. I'd ask that you please introduce yourself. So we can't hear you.
Yeah, I think they're going to turn the mics on at the back there.
Is this one on? Yeah.
Yep.
Okay. Simon Ania from TomTom. I have a question related to the labeling, because labeling to me seems still relatively voluntary. Have there been considerations to use the CE mark we already have in place as a part of the RED directive to put some teeth to this? Because the CE mark is about radio equipment. Most IoT have radio equipment. There's safety stuff in there. There could be a very easy delegated act from the European Commission stating something like you need to have labels and you need to self-certify, and then if you don't comply, it's an economic offense. So that would put some teeth to it, but most importantly, it would also allow us to block shipments from China of bad IP cams in the port of Rotterdam. Has that been considered already?
Shall I answer?
Please,
yeah.
please.
Thank you for your question. We are now basically in the design process of this trusted IoT environment. It's not quite clear whether we want to go for a labeling system. This may be or may not be the case. You may also use a standardization process to respond to the challenges we've just discussed. We would basically inform you whether we launch a public consultation on that, and there we'd probably give some options on how to design the labeling system, and there you would be invited to then reply. And so the work on this topic is just started. So we are new at the beginning. We are quite new, and we've already organized several events with stakeholders. If you are interested, please follow us on Twitter and you'll find out news. But the option you propose could be one of these options on how to implement it. The label should not be seen as a protectionism mechanism. It's not about this. It's about giving the consumers choices to decide. So when they basically buy the IoT device, they are aware of the vulnerabilities of such a device. That's the main idea behind it's really creating the trust that the consumers need and going further towards helping deployment.
But my point is maybe that ambition level is not enough. The CE mark protects consumers against exploding batteries. It probably should also protect them against insecure devices in some way.
Yeah, that's another option. Yeah, thank you for the option.
Next.
Still not working, or is it working?
Yes.
Okay. Tobias Morsches from Datenschutzraum Germany. You spoke of apps that are able to get on the motion-based the password. The question, we have already the data minimization. Do we need a regulation on a limitation of accuracy, density, or transparency for accuracy, density, or for maybe a user option to say how accurate the data I want to give? Something like that.
If I understand your question correctly, I don't think that additional regulation in the form of a regulation or a directive is the answer to those issues. I think where is more needed is pragmatic guidelines interpreting, because all of these principles that we're talking about, transparency, accuracy, and so on, they're already in a number of regulations, such as the GDPR. What we now are looking for, and they have been empowered, is that the Article 29 Working Group, the European Data Protection Board, amongst others, and the local DPAs, would come out with something pragmatic and that holds the, let's say, that is valid throughout EU, with respect to those type of kind of requirements. I think I would look it more into that, because they are easily more changeable. They can follow up the developments rather than a regulation, which I think, to me, is still kind of sets the framework where you will live and where you will use these devices. But that is my personal opinion.
Yes, it might be interesting to connect the two. I don't know, because this is all very new. Tingling. Yes. To say, okay, I give you my data for service, the exchange, so that's a contract. Now, you may do other things with that data. For instance, use it for scientific research or other stuff, but on the condition of making it in a specific way less accurate, or pseudonymization. But a colleague of mine once wrote an article about the right to inaccurate personal data. So to provide data that are inaccurate to protect yourself. And I think it might be interesting. I'm sure metrics can be developed to even have a slider to say, okay, you may use it for medical research, non-commercial, at 0.9 accuracy, but if it goes to the pharmaceutical industry, I want it at 0.2. I'm just saying something, but I think this is technically possible, and it might, for secondary use, basically that's your idea, it might solve some problems.
Thank you.
Good morning. I'm Yasmina Sbahi from a Moroccan bank, Crédit Agricole du Maroc. I have a question about the data protecting impact assessment. I want to know if this assessment will be conducted by the companies themselves which use or transfer data. If so, don't you think that that will be a risk that those companies manipulate the numbers and the results of this impact, of the assessment, sorry. In other words, wouldn't it be more efficient to oblige those companies to delegate this assessment to third independent parties? Thank you.
Yes, so according to the GDPR, the data controllers are in charge of organizing this type of work. How they want to outsource this or how they want to organize it, it will probably be entirely up to them. But we are now working on the implementing guidelines for the GDPR, and there is a team putting forward provisions on how to implement some of the articles. So if you want to get engaged in this discussion and you have options, I advise you get in touch with these colleagues.
I also think the threat of 4% fines on global turnover would affect the incentive of manipulating such processes.
Yeah, and I think what we've seen is both ways. Companies starting out to maybe first, because the problem now today, privacy impact assessments, there's some guidance, but there's no yet clear standards. However, that has not stopped, as we've seen, clients to start already the privacy impact assessments, sometimes in the beginning with some help from outside, but then doing it internally. The idea is that you embed it in a process that is easy to use, because this is not just one process a year or one privacy impact assessment a year. You're talking about maybe on the application level 100 or 1,000, something that you have to go through. So I think doing that internally, and I agree with on the fines, but also on the fact that you will have to, at one point in time, demonstrate compliance. So you will have to show what type of risk kind of decision you have made on the basis of what type of data. If that appears to be false, you will be held accountable for it. So I think to the extent, if you're talking about environments where there's a high risk, if you're talking in the medical or in a financial, that you're talking about if you're in the private banking sphere, and some of the CRM systems have too much information on kids of wealthy clients and so on, that risk is going to be very high. And if somebody would like to try to manipulate that, I think that would be at the core of any internal compliance failure. So I think I agreed, it's not a question of external or internal, it's the fact that it's being done, and it's being done intelligently. Because at one point in time, you have to look forward. What clients now are facing is, going forward, it's fairly easy. Going backwards to legacy applications and legacy environments, that's something else. And there you will have to do, and I'm sorry for the consulting word, a risk-based approach, but you will need to prioritize on the basis of what type of information is in that application, how is it used, how is it combined, and so on, because you can't do everything at the same time. But the fact that you do a privacy impact assessment, I think, is now the crucial part. Who does it? I do not think that that matters, or that should matter in real life.
Thank you. Before we close really quickly, I'd like to take advantage of the fact that we have John here, who has a completely different perspective, perhaps. And so, John, I was wondering, as a telecom and network provider of hardware and services, what are the big themes for IoT that you're seeing in your world?
Yeah, I was trying to keep quiet in this whole session and not answer any questions. You know, Huawei, we operate across multiple industry sectors, consumer, enterprise, carrier network, and so on. And there's no single IoT environment. There's lots of different types of IoT for lots of different industry sectors, segments, purposes, uses, etc. And as was discussed in the last session, bringing those together and trying to have a common approach to security and privacy will be extremely challenging. But it is something that we are actively working on, and I've been saved by the bell, literally, saved by the bell. So with that, I'm going to thank Professor Antón and the panel for what I thought was a fascinating discussion. So please join me in a round of applause for them. Thank you very much.
Thank you.
I won't be blue, 'cause love will follow